Hello everyone, so today we're going to be looking at portfolio optimization in Python. First I'm just going to show you how to use this program to create a diversified portfolio for yourself, and then we can look at the finer details and just go through the math that I implemented to make this happen. So to get started, you just run this file right here, find optimized portfolio, and then you call its main function to get started. So now it's going to prompt you for just a few different parameters. To begin with, it's going to ask you for the list of securities that you want to include in your portfolio. I'm just going to put in the big four tech stocks: Apple, Google, Amazon, and Microsoft. And now it's going to ask you for a period of time in which it's going to retrieve data from for this model. So let's say I'm an investor with a really long time horizon. Let's say I want to do 15 years worth of data in the not so distant past. So it's going to retrieve data between those two dates and create a model. Okay, good. So this is a feature that I included in this program to make it run a little more smoothly. Google actually did not go public until August 19th of 2004. And so our two options are to either exclude Google from our analysis and remove it from our portfolio, or we can just skip forward to this date and begin our analysis there. And so that's what I'm going to do. Let's say I really want Google in my portfolio. So I'm going to put in skip. Okay, so let's start. So this is the model right here. Let's start by looking at this plot. So what this plot is showing is called the efficient frontier, and the efficient frontier runs a line through through a bunch of points where each point you can think of as being a portfolio, where that portfolio is optimized with respect to its standard deviation. So for any given return, it'll plot a point at the smallest possible standard deviation given that return. So let's say you're an investor that wants an expected daily return of 0.1%. The smallest standard deviation you can hope for, that you can get given the securities that we entered and that period of time, is about 1.55%. And just to remind you, roughly 2/3 of data points occur within one standard deviation. So 2/3 of the time within that period right there, if you wanted a expected daily return of 0.1%, you'd be getting a return of negative 1.45% and 1.65%. And additionally, just to make this more clear, 95% of the time, the data occurs within two standard deviations. So that would mean, again, within this period of time, the portfolio that gets you 0.1% on average daily, you'd be seeing a return between negative 3% and 3.2%. And that sounds about right, given that we're doing just tech stocks. It's not really that diversified. So yeah, 95% of the time you're going to be getting between like negative 3% and 3% every day. Okay, so let's say we're happy with how this model looks. We're comfortable with the returns with respect to their standard deviations, and we want to backtest it. Well, actually, let me just first ask the question: are we happy with how that model, how it performs? So here I just noted the S&P performance over roughly the last 20 years. So it averaged a daily return of 0.0288% and a standard deviation of 1.255%. And you can see here, we're actually, with only a small increase in standard deviation, we're getting a really, really outsized return. We're really outperforming almost 4 times, a little over 3 times actually. So we're really outperforming the S&P. And if you're a critically minded person, you should have from the beginning noted, wait, he's using this model and cherry picking 4 of the best performing stocks of the last decade, and I would completely agree. If you want to review the efficacy of a model, you really need to try to be as unbiased as possible. And I actually picked these securities on purpose just because I wanted to show you that point. Because when I was first learning how to optimize portfolios, I would get very confused. How are my models outperforming reality so much? I must be doing something wrong. Well, the truth is, I was just cherry picking. I know that these stocks have performed very well, so obviously it's going to outperform. I know that, even starting all the way back in 2004, going to this date or going to the present day, these stocks have outperformed the S&P. I know that, so you just got to be really careful just to show you. So this is what we're doing right now, but if you want to be more unbiased, so this one has like American Airlines, Procter and Gamble, Waste Management, United Healthcare. So just this is what this gave me more realistic results, and this is an emerging markets ETF, and this is these are long-term bonds, treasury bonds. So that's how you would if you really want to see how well these techniques work, to how predictive they are, you're going to have to try to be as unbiased as possible with how you choose your securities, how you choose the securities you're including in your portfolio. But just to keep things simple, let's say we like how this looks, we're very happy with its performance, and we want to back test it. So you can also restart, by the way, if you want to change things up. But let's just move forward. Let's back test. So there's two ways of back testing that I sort of jokingly called real and simulate. What real does is it takes the allocations here of these optimized portfolio and applies them to a second period of time. Okay, so yeah, we're putting in real. That means we're going to, again, take these allocations, these optimized allocations, and see if they're still as optimal during a different period of time. So let's say we want to test 10 different portfolios, and we want to just throw this entire efficient frontier in. So let's say maybe this is like negative 0.05, the bottom here, and then let's bring it all the way to the top, 0.175. And let's say we want to pick up where we left off. So test it from this date, the beginning of 2015, all the way to roughly the present day. So 2020, maybe 520. Okay. So now it's just going to take each of those portfolios and equally spaced along this frontier and tell us how they performed. Okay, so you can see roughly a sideways parabolic shape again, but what you should notice, and that I found very interesting, is that, so I ordered it so that it starts at the bottom here and moves to the top. So backtest 1 refers to, if you remember, I punched in negative 0.05%. So that refers to the smallest. We thought that would get us the lowest return, but when we backtest it so we created this model using data, if you remember, from 2004 to 2015, and now we're applying that to the period of 2015 to 2000, roughly the present day, and it's actually flipped. So this is this refers, backtest 1, this point right here, refers to what we thought would get us a return of about negative 0.05% on a daily basis, but in fact it's really outperforming expectations. Green, by the way, indicates higher returns than what the model predicted, and red indicates lower returns than what the model predicted. So why is it, if we just want to look analytically a little bit, why is it that it pretty much flipped? You can almost think that this, so let's say backtest 1 would have been right here, it flipped to being up here at the top. So that is because, if you remember, Microsoft had as you move along this curve, Microsoft was the worst performing. If we go all the way to the top, Microsoft had the lowest standard deviation, meaning we're going to use it more as we move down on this curve, or we're going to allocate more towards it, and it had the lowest return. So yeah, as you decrease your returns, you're going to be allocating more and more towards Microsoft. So you can see, yeah, to get that negative 0.05% daily return, we leveraged up on Microsoft, and that actually, against the model's expectations, Microsoft really changed its performance during the period of time of 2015 to the present day. Microsoft really outperformed, did better than most people would have predicted, and so that is why we've got this flip. And as we move down, let's go all the way to backtest number 10, you can see we're actually shorting Microsoft, and so that's why we're getting much lower returns than what the model predicted. And so yeah, this is just a good way to look at the efficacy of the efficient frontier and see how well it can predict how performance is going to look like in the future. And you can see it's not perfect. I'm not claiming that it's perfect, and that's why you backtest. And we're also going to note the average daily return using that these allocations. And by the way, just negative reflects shorting. So there's a bunch of different ways you can short a stock. You can look into that yourself. But point is, these are the statistics giving that allocation during this time period using a model created during that time period. Okay, so you can follow along the curve and yeah, again, analytically look, why did the frontier look this way here and now look this way flipped during a different period of time? Okay, but let's say we think Microsoft is going to continue to outperform, and we want to use, maybe we're comfortable with a standard deviation of about, what is this, like let's just call it 1.8% with a daily return of 0.12%. So what I'm going to do now is use the second backtesting technique, simulation. And that refers to Monte Carlo simulation, where it's just going to get random z-scores and from a normal, we're assuming that stock returns are normally distributed. And you can look into that. That roughly holds true for the most part. Okay, so now we're just going to simulate, and as I said, we're going to simulate a portfolio that has a daily return of 0.12% and a standard deviation of 1.82%. Okay, and let's just simulate 1 year, keep things short, and let's run 20 trials so we can converge on some sort of accurate mean. So yeah, as I said, you should be skeptical. This is a completely ridiculous, so this is 1 year. You shouldn't expect a 50% return within a year time frame. And that's again because we cherry picked. So this shows the power of bias. If you cherry pick, if your inputs are crazy, your outputs are going to be crazy. So each one of these is a simulated return given these parameters right here. And each one of these is just a simulation of what could potentially happen. But what you should be paying attention to are the median and mean. So this is it'll converge on a certain number, about maybe 150, and so about a 50% yearly annual return is what you should expect. Okay, so that just about sums it up. That is what that's what this program does, and now we can start getting into the math that I used for all of this.